yesterday. Filling in pretty much from notes, because we talked about what can and can't go inside of cosine and sine inverse, what can go inside of tangent inverse anybody. He says bring me anybody, but all of them, now guys, we double, triple checked. These are highlighted in your notes, right? What can come out of a sine inverse? Only negative pi over 2 to pi over 2, including. What can come out of a cosine inverse? Only 0 to pi. What can come out of a tangent inverse? Only negative pi over 2 to pi over 2. Number 4 was just the idea of an inverse. Number 10, you're going backwards from 1. And for some reason, I guess I've been singing it to myself and not really singing it to you guys. You guys know there's a song to the cheater chart, right? It's not near as, I don't know, straightforward as Pop Goes the Weasel, like the quadratic formula. It's not near as exciting as that. But there is a little bit of a song to it. And why am I bringing that up? What did you have to do in number 10 without using a calculator? Cheater chart or unit circle backwards and say, when on earth is tangent 1? Well, I guess it's 1 when you have sine and cosine being the same, so that y over x or sine over cosine is root 2 over 2 over root 2 over 2, which happens at a 45. That's a lot of thinking, and that's assuming you know it all. Because I remember yesterday, and maybe I didn't update it. Here, this one, right? Oh, 16 is there. Okay, we'll need to talk about that. Thanks. That's you guys keeping me honest, because remember I might have switched a couple things. What number are we on? 10. Okay, so 10, coming backwards from tangent to pi over 4 could be 1 left. I know the tangent row. Square root of 3 over 3, 1 square root of 3. Oh, 1 happens in the middle. What's the middle of the angles? Pi over 4. The song of the cheater chart, just in case a few of you guys. Does anybody sing the song when they do the quadratic formula? I'm not saying that they will get 100 quiz right now, but the song kind of helps you or has helped you in the past.
I would not know it if I didn't sing that.
Okay, let me see the hands of people who like the song helps. That's it? X equals negative b plus or minus square root. No?
No, like I know.
Oh, sorry. Quadratic formula. Sorry. I'm asking them this first. X equals negative b plus or minus. Who says the song helps? Okay, like half the class. Here's the song for this. 1, 2, 3. 3, 2, 1. All over 2. Now it gets awkward because there really should be square roots as well, and it's not really in the song. Square root of 3 over 3, 1 square root of 3. Wait, stuff's missing. Yeah, but sine counts up. It starts at 0, ends at 1. Cosine counts down, 1 and 0. Tangent says your cosine over your x. 0 over 1 is 0. 1 over 0 is undefined. And some of you just think about the axes different anyway, because, I don't know, it's easier in your brain to think about the points. So some of you don't even really think about those, because you would just think about this. But, am I reminding you of this song again? Square 1, yes, pi over 4. Done. A lot easier than thinking sine over cosine, the y over the x, and it needs to become a 1. Magically, something goes away. Oh, it's a lot of work. But hold on. Lauren, I got you for number 16. We're going to come back to that. If you guys... Oh, no, thank you. You were looking ahead. But let's really quickly. 102 and then 16. Got it. For number 26, can you guys skip ahead to that one really quickly? Why would you not need to do this one with the cheater chart or the unit circle? Square root of 3 over 3, 1 square root of 3. It's not any of those. Haha, calculator, second tangent. Wait a minute. You guys help me out. Is that a radian or a degree? Yeah. Oh, I think it's a radian because there's no degree mark. Did any of you guys do degree mode?
I changed it.
Oh, you changed it to radian? Did they say in radian? Who has directions? Because degree would have been okay if they didn't say radians. I'm just looking for the other right answer. Does anybody have the degree answer? Because you're right. You're just in a different... Jason. Okay, 87.709 is also correct. So you could have done the radian answer or the degree answer. If they don't tell you, you could have done either one. Okay, 16. Let's go peek at him really quickly. I have the book right here because we skipped over him in the evens. 16 asked you for arc sine of... Now, some of you are like, boom, I got that one because it was easy. Some of you guys are like, I don't know. 2, 3. Oh, 2 happens in the middle. Oh, that's a pi over 4. Dun, 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 dun. The cheater chart can help a lot with inverse trig because it has summarized in one quick place. And guys, you know the order in the sense of, or you can know the order. If you're saying 1, 2, 3, 1 goes with the first angle, second angle, third angle. Now, a few of you, I forget if it was the unit circle quiz or if it was actually on that quest, but a few of you messed up the order. What does that do if you write it wrong? Yeah. So maybe you had the 1, 2, 3, 3, 2, 1. Maybe you had that all, but you wrote like pi over 3, pi over 6, pi over 4. If you go messing that up, you have to know the order in the sense of it goes 0 and then 1/6 baby slice, 1/4 bigger slice, 1/3 bigger slice, 1/2 biggest slice, right? Like you have to know what the angles are because if you mix these up, then your whole chart's not going to help you. It's going to get actually every problem wrong, and that's a bummer. Jordan.
Is it easy for you to just see the unit circle?
Totally fine. I'm just trying to give people a place to go. Especially when like this is one little baby problem and you have to go backwards fast.
Yeah, that's the only thing that comes up, but for homework, I think I have it.
Yeah. Right, which is why I'm trying to give you like a quick reference to have memorized where you can like quickly get the answer without having to like, oh, I have to draw the whole and then. Because if you're always using the actual unit circle, you have the idea down. It's just on a test, would you be able without the circle drawn? Yeah, definitely, definitely. I'll sing it a few more times. So what's the final answer, number 16? Pi over 4. Should there be more than one answer? No, even though if you're looking at the entire circle, this happens also in the second quadrant at 3 pi over 4. Remember, inverse trig says only one answer. Not all the possible answers, only one. And specifically, only the one that's inside the domain restrictions. Yeah, the domain restrictions. Okay, Lauren, let me know when there's another one missing. So number 26 was plugging into your calculator. Already talked about how the Jason 87 point something was the degree. Number 40. This is where the cheater chart gets hard, which is why I drew the little x and y axis. Because the cheater chart, cosine, 3, 2, 1, pi over 3. No, that's for 1/2. Where's cosine 1? At 0. So cheater chart gets a little bit hard for the axes. But if you guys know that cosine is x, well, where is x negative? Here. Oh, that's pi. Okay, done. Where is cosine 1/2? 3, 2, 1 at pi over 3, but, oh, check the sign. Negative 1/2. So if you think to the highlighting, cosine is allowed to go between 0 and pi. So if it's not 1 pi over 3, what's it have to be? The second quadrant, 2 pi over 3. So the positive one would be the first quadrant, negative would be the second quadrant. Cosine highlighted in your notes only goes between 0 and pi. So if it's negative, it's not the first quadrant, it's the second quadrant. Wait a minute, that's not even a cosine inverse. It's all right, take it back. Let it out. Let's go. Cosine of pi over 6. 3. Are we okay? We can rise above. We can rise above. We're fine. You guys. I need all of you guys to like have like a little Sunday school class of like kindergartners so you can be like, why are you doing this? And then you know how I feel. Anyway, so. But then you'll know like the, aw, you're so cute moments too. And then everywhere in between. Pi over 6. 1, 2, 3. Nope, 3. Square root of 3 over 2. Cold. It's warm in here. Number 42. Did you guys end up solving for theta by taking cosine inverse of both sides? You didn't have to write arc cosine. You could have written cosine inverse. Totally fine. Cosine inverse, totally fine. Number 52 was some of those nasty ones that we saw yesterday, where you have an arc cosine and a cosine, and you're like, oh, cross them off. Answer is 7 pi over 2. Ha-ha! But that's why it's in the note, because that's what a lot of people would think, cross, cross. And the people that think that are doing a good job. Inverse with original cancels. But what did we say? Highlighted in your notes. Cosine inverse is allowed to go between 0 and pi. That's it. He's way too big. He's 3.5 pi. So we have to think about, well, hold on, where is that guy? Where's 7 pi over 2? If you have 3.5 pi's, where are you at? Well, there's 1, and then there's 2, and then there's 3, and then there's a half. Okay. What's another way of getting there? Negative, but cosine's not allowed to go negative. Sine inverse is. Well, I think we better think about, isn't cosine the x? Okay, so for what angle in the legal range is cosine going to be 0? Whenever you're doing trig inverse, you don't care about it necessarily being at the exact same direction. It's not always allowed, but the value has to match. Hence why we have 1/2 pi. It was the only legal angle that has cosine equaling 0. And that's like that weird example we did yesterday. It's on the video if you guys want to re-listen. When you have an arc cosine and a cosine, and they don't just cross because of restrictions. Okay. 54. How'd you guys do on this one? There was a constraint, but the constraint was just the first quadrant. Oh. Why are we drawing a triangle? Because what's being given to you when you have an arc or inverse trig with a fraction? Who is this guy? It refers to the triangle, and what part of the triangle, Matthew? If it's a sine inverse. Opposite and hypotenuse. So we make a triangle and say, hey, you're my opposite. You're my hypotenuse. Adjacent, easy. It's one of the Pythagorean triples. It's a 3, 4, 5. Or 25, 5 squared, minus 16, 4 squared, equals 9, which is a squared. So a is equal to 3. But the point wasn't just drawing the triangle, wasn't just filling in the adjacent missing side, but was also answering the question. They wanted secant. Choshikao, who's secant? Sha, hypotenuse over adjacent. Bum, bum, ba-dum, bum, bum, bum. Or take cosine and flip it. Also like the example we did yesterday. And last but not least, I think this was, oh, sorry, Lauren, 102, right?
66.
Oh, 66 we missed? Lo siento. What was 66? Oh, you know what? After yesterday, I was a little worried that just one problem wouldn't be enough. So I gave you one more. This one also says, hint, draw a triangle. Sorry, guys, that's really tiny. But you have it written there. You have it written there. You're fine. You're fine. You're fine. Okay. Whenever you have something in an inverse trig, doesn't it stand for something in a triangle? Two somethings. TOA. Tangent. Wait, tangent always has two sides. So when it just gives me x, what must be the denominator? Because this is supposed to give me 2, not just 1. Yeah, understood. If there's no denominator, you can just put over 1, and then we can say opposite and adjacent, because tangent gives me opposites and adjacents. And then do you remember what we did yesterday to fill in the missing side? Can't we make this a c? And we can do a squared plus b squared is equal to c squared. And then can't we do 1 plus x squared is equal to c squared? Square root both sides. If you want to be a smarty pants, what else could you put? Plus minus. Unless they tell you something about the quadrant. So now I can plug in. And what's this all for?
Let's find side.
Good. That's the objective. So now that I have my triangle, sine, that's easy. SOHCAHTOA. Look at your triangle. Opposite is? Oh, hypotenuse. Oh, well, maybe they rationalize it. That's kind of gross. But I'd be just fine if you stopped there. I guess they could rationalize, multiply top and bottom by the square root. But, okay. Sine is equal to opposite over hypotenuse. If you got there, I would be more than happy. Sorry, did you guys get that okay? Yeah. 66, and then 102. 102 was a little tricky unless you looked in your notes. Some of you might want to grab out your notes. We're going to section 4.8 or back to 4.8 in just a second. Some of you might want to grab out your graphing calculators too, because we're in section 4.8, which is the application-y section where we use our calculators a lot. But why am I asking that? Because they're asking me about what arctan is doing, and I don't know what arctan is doing unless I look at his... Yeah, I was thinking that whole section, the restrictions, the range, the domain, and also the graph. Can anybody find in their notes where we wrote down what arctan looked like? Section 4.7? Not the beginning, maybe more in the middle. That's what normal tangent looks like. I need arctangent or inverse. Yeah. Remember? This is inverse tangent or arctangent. And we had, I think Joe and I were talking about the day before, the vertical asymptotes at, and they're saying, what's going on as x goes negative infinity? Am I going right or am I going left? Oh, so as x goes to negative infinity, the y's, or the whole thing, if you want to think about it, it's y equals. What are the y's going to?
Approach that value, but never get that value.
But it's not asking for getting to, it's just asking for approaching. Dun, 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 dun. Because negative infinity has us going left, and the left side goes down to negative pi over 2. Closer, 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 but as Joe said, never hitting. Okay. Sorry. Now back to our last one, which is, I think, 104.
Yeah.
Last one.
And,
I'll freeze the screen and we'll peek. Let me give it a second. This was a word problem, I think, right?
yeah.
Setting up a picture, your opposite and your adjacent. Oh, it doesn't like 104. I can't get a picture of it. There are certain pages of the textbook my document doesn't like. It's kind of lame. And then 111, 127, 131 were all odds. Okay. Once you finish grading, guys, check out your homework and see if you have any odds, especially along the way, because evens you've had a chance to think through as we grade it. You can still ask on evens, but specifically odds that you still need help on finishing up. Any questions that you might have. But on this one, once you set up your little like, oh, that's my opposite, that's my adjacent, he's my angle, arctan or tan inverse, totally fine. Tan inverse both sides would get you theta. And then they just said, hey, plug in, cool, calculator. Hey, plug in, cool, calculator. And they were nice and gave you radians or degrees. Which means any long answer on the quest I could take, or I would take radians or degrees. Okay, odds. Anything? Jason? 131. Anything else besides 131? Tyler? 71? I heard a 90-something. Yeah. 19? Okay, let's start with those, and then if we have more, we'll go from there. Number 19 gave us, using a graphing calculator, I think. But it was to graph. Was that tricky? Here, we'll see. Number 19 says use a graph, use a calculator, that's what this little symbol shows, to graph this one and this one in the same window. So basically, it gets a little confusing, Selma, because you're going to see the cosine like this. Do you guys remember how big inverse cosine is? Does it go like all nice and snaky like it's supposed to? No, so it's going to look kind of awkward because it's going to actually just go like here. But the point is, does what you see flip across? And the answer would be yes. It's just really awkward because it's really hard to see on your graphing calculator. So I was trying to show you that if you tried to graph them both, you're not going to see it. And the reminder is because it's supposed to be snaking and inverse cosine doesn't. It has a beginning and it has an end. But that's good enough. Yeah. 71, Tyler? Okay. 71 is one of the funny trig with arc trig. Hold on, let me zoom in because this is just way too tiny for you guys to even see. Okay, there we go. All right, Tyler, when they give me an arc cosine, remember this is a ratio. This is a SOHCAHTOA, so my adjacent over hypotenuse, because we're working backwards with inverse, is what I would put into my triangle. Unless they gave me any sorts of constraints. So adjacent and hypotenuse, don't know this guy. I'm just double checking they didn't tell me like what quadrant to draw it in, and they didn't. So I'm just going to do like a basic triangle like I did. The objective is tangent. So what I want is opposite over adjacent, but what's the problem? Who am I missing? Yeah, but I know Pythagorean theorem. So I can say x squared, so let's call him b. B squared is equal to 3 squared. So b squared is equal to 9 minus x squared. If you want to be super snazzy, you can put plus or minus. But as Joe and I were talking about yesterday, they probably just choose the positive because it's more realistic as a measurement. And once we have this, we can go ahead and, if you want to be like the book, you would just choose the positive one. Not thinking about a circle, just thinking about a triangle in real life, being a positive measurement. And now I can just say, who's my opposite? That guy. And who's my adjacent? So the key, I think, is seeing that this guy gives you two sides. So then you make your triangle, fill in your missing, and now you're ready to do what they asked you. Is that cool? Yeah. Everybody else good on 71 at this point? Okay. Jason asked for number 131. Any other questions before we go there? I think my book doesn't like 131, so I'm getting out an actual book. Which one? Yeah, 54. Oh, super similar. In that, this one's actually a little bit easier than 71, because this one they give you numbers. Oh, not this one? Oh, got it. 57. Okay. So then, Salma, when you look at this, the 5 over 13, I need you to think triangle. Triangle with one side that's 5 and one side that's 13. And we have to look at sign to know which side is which. So if it's giving us a sign, where would 5 go? Opposite. Does that make sense? Because it's a sign, and so I'm thinking of opposite over hypotenuse. So the 5's going to be opposite. What's the 13 going to be? Hypotenuse. But 5 and 13 don't give me this one, but that's okay. Pythagorean theorem. So then we can do a squared plus 5 squared is 13 squared. So a squared is 169 minus 25 is 144. Another way of thinking about that is, this is actually another Pythagorean triple. But you guys might not be as familiar with the 5, 12, 13 triangle. It's like the 3, 4, 5, but bigger. Well, and proportionally a little bit different. But what am I supposed to be finding? And who is cosine? Adjacent, in general, adjacent over hypotenuse, good. And adjacent over hypotenuse is going to be, well, if we're doing it like Joe said, like just keeping it real, then we'll just think about a positive 12, so then 12 over 13. I'm making sure they didn't tell me to put it in a different quadrant, though. Nope, they didn't, so we'll just keep it positive like a real triangle would have it. 131. You guys can grab your notes out and calculators out if you haven't yet to be ready for section 4.8. I'm in 4.8, sorry, wrong one. 131 gives us, aha! Jason, I'm going to go to notes for a second, and here's why. This was from the big highlighted section that we did towards the end of notes. Because ooh, that looks so much messier when you zoom in. Anyway, sorry. Number 131 gives us the problem arc cotangent of 5/3 and says we're allowed to use our calculator. Here's the struggle. When you guys see cotangent, what do you always think? But using your calculator, what do you always think? Cotangent, isn't that just 1 over tangent? It is normal, but inverse isn't. So cotangent of, I would do 1 divided by tangent of, but the problem, what's our formula remind us of? To do cotangent inverse, I flip something, but I don't flip him. It's not 1 over tangent inverse. Where must I flip? The answers will be different if you do it in the wrong place. I flip on the inside. So Jason, what are you actually going to be doing? The only second trig button that could work or could help, but not of 5/3 and not a big old 1 over. I'm doing it of 3/5. The nice thing is both of those will take us to the exact same triangle where we have either a tangent of 3/5 or a cotangent of 5/3. I don't go changing the 1 over inverse. I go changing the sides, and then I'm good. Is that cool? Degrees or radians, either one, I don't care, you're good. But guys, real quickly for the quest, or even just in general for showing work, if you're in degree mode, what do you need to be labeling every angle that comes out of an inverse trig? With a degree mark, good. All right, cool kids. With that, section 4.8. Shoop, 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 shoop. I don't think we needed that one after all because we went over that word problem and no one asked about it. So here we go. Shoop. From yesterday. Talked about that, did the sun and the statue. It was a little bit rougher than we had hoped, but we got there. The passenger and the plane. Let's finish this one off really quickly, just in case. Just in case. It might be helpful for homework and or might be helpful for the quest on Friday. As Lauren already brought up, the review for the quest is due on Friday, but the earlier you start it, the better, right? And hopefully, at least a few of you were able to start 4.8 last night, or the section won't be too bad. You have your calculator. You don't have to necessarily, for this part, be thinking of the cheater chart. And you guys know how from last quest, the test will probably have 2 parts, 1 mental math and 1 calculator math. Does that make sense? Cool. With this one, you actually had a picture that you were able to work with, which helps a lot, but the triangles weren't drawn in the sky. Aren't we used to drawing triangles to the ground? Like, we're kind of used to that. There's a ladder leaning. Okay, cool, there's a triangle. There's a sun shining on a statue. Cool, there's a triangle. It's a little bit harder when there's a dude in a plane looking down at towns, and you're like, where's the triangle? It's literally in the sky. I know it's awkward, but figuring out those dimensions of the triangles in the sky will help us with figuring out the distance on. So yesterday we figured out that with this angle of 55, the opposite would be 10, because that's how high the plane was. It will all be congruent if you want geometry. So the opposite's 10. The adjacent is a distance. It's in the sky, but it represents on the ground as well. So we set up a little tangent equation, opposite over adjacent. For the other town, the second town, we can also talk about how it's 10 up, or the adjacent, opposite will be 10. The adjacent is a horizontal distance in the sky that's also on the ground. So I set up that equation. And then we find the distance between the 2 towns, we subtract. Some of you know we need to keep on going. So I'm going to quickly rearrange these formulas, which you guys had a little bit of practice of in other homeworks. I'm going to divide by tangent of 55, which is the distance from the plane to the first town. I can do the same thing over here, multiplying by y. Oh dear. 28? Guys, these are all things your calculator can do, right? But if you do it right now, if you get a decimal right now and then start writing the decimal and then plug in a decimal and then you get another decimal and then you start writing that decimal, is that decimal round and round and round, your answer might be just a little bit off. So I think it's a lot easier just to, plus I don't calculate what x equals, I've gotten what y equals. Who's the longer one according to the picture? The y, which has the smaller angle, it's further out. Maybe that makes sense visually. Y minus x is what I need. So I'm actually, in my calculator, just going to do one thing. The distance, typing in all at once, will be 10 over tan of 28. What mode can it be in? Degrees according to the problem. So careful on the quest and in homework. Especially for 8. I think almost everything will be degrees. Minus 10 over tangent of 55. Is anybody putting this in as we speak? Electronic devices out, but not some of them being used properly. But long story short, do you guys know how to put it into your calculator? Yes. Do you know what you should label all of this as? Kilometers. Okay, we have the idea, right? Have your calculators out. We'll probably use it in a future problem, but for right now, we're going to move on. Ooh, all right. Brand new problem. No picture given. I know, the other one wasn't drawn, but I drew it for you, and it said C figure. This one, though. All right. What do you guys think? If we have a plane overhead, probably ground is important, right? Elevation is how high off the ground.
Yes.
Plane, up here in the sky somewhere. We'll call him P for plane. Well, I don't think we've gotten that far in the problem, Joe, but good job looking ahead and seeing that. Because Joe's saying the plane isn't just staying in the sky in one spot, which we know that. We know that. We're watching a plane come towards us. Think you're like towards Van Nuys Airport or something. There's a plane that's coming, okay? So you're probably, I don't know, over here somewhere. See a plane off in the distance. Pretend you have legs. There you go. You have a plane off in the distance. Your arm is really, really long, awkwardly, and you're touching the ground. Anyway, it's approaching, which means, yeah, if the plane is here, if it's approaching, well, some other time it's over here now, right? So we could do like a P1 and a P2. It was there and now it's here. It's approaching, getting closer and closer to you. The angle of elevation is 16 degrees. That's a very low angle, right? So we'll make that be the original one, which would technically be, yeah, way lower, but we're just trying to make it so the picture is easy for us to visualize. Then 57 degrees, well, that would be when it's closer, right? 1 minute later. Huh. Wonder why they told me time. Approximate the altitude. Wait, they only gave me angles and they didn't give me any sides. This is impossible. Even for trig, I need 2 pieces of information per trig. And they only gave me 1. But what's the pieces of information in a word problem? Sometimes you have to do process of elimination. I used him. What haven't I used?
Miles per hour. A minute later.
Or, good. There are 2 things I haven't used. I haven't used that it took 1 minute to go from here to here. Oh, so the distance is 1 minute?
Yeah. So it's 1 over 6.
Took 1 minute. Oh. Any chem people, any dimensional analysis people, think if I have miles per hour, maybe I can use 1 minute to somehow help?
1 minute, 160 hours. No, yeah. 60 minutes.
Do we have to do hours to minutes first?
Yeah.
Okay, first we just have to get rid of the hours, so we can do minutes. Then I can say, once I have the minutes, what can I do? I can get to miles by multiplying by, okay, hold on. Distance equals rate times time. It's an old formula from like physical or something. Equals rate times time, the DIRT formula. I have the rate, and now I have the rate in miles per minute, and all I need to know is, well, how long were you going? Well, 1 minute. What happens if you multiply by 1 minute, which is technically over nothing? I'll get how many miles? So how many miles? And why is that helpful? That tells me this guy. How many miles the plane went is going to tell me this distance, so therefore I can say 550 over 60 will be 55 over 6, which I don't think really reduces. Yeah, it's going to be a nasty decimal. So we'll just do the fraction because it's easier in my head to keep track of. 55 over 6 miles. Wait a minute, what are we supposed to be finding? How high the plane is. Isn't that this guy over here? Oh, but they're going to be the same in both triangles, right? Huh. But what don't I know? I don't even know the full side of either triangle. But guys, how many equations do you need for 2 unknowns in all of algebraic math? For 2 unknowns? Yeah, substitution, elimination, all that jazz. You needed 2 equations for 2 unknowns, 3 equations for 3 unknowns. 2 equations, well, good thing I have 2 triangles for 2 unknowns. So can't I do something like tangent of 57, that's the bigger triangle, equals x over y? And can't I also make an equation? 55? I think it's 57, right? Yeah, 57. Oh, I hadn't gotten there yet. Thanks, Joe. Tangent of 16 degrees is equal to, its opposite is still x, but its adjacent, as Joe's been trying to tell us, is y plus 55 over 6. We have some options. I think the easiest way is just to multiply up, though. You guys agree? Like, get rid of that division. That's gross. So I can say x is equal to tangent of 57y, and x is equal to tangent of 16 degrees times y plus 55 over 6. What can I do if I have 2 equations, both with x equals? Basically, yeah, I can substitute this in for the x, or I can set them equal to each other. And I'll end up with tangent of 57y is equal to, I'm going to do a quick little distribution. I know you might not like it, but the long story short, I have y's in 2 different places. I have to bring them together, which I could do. Nasty decimals, because I have a calculator. So what if I were to subtract this guy to the other side and pull out a y? Can you guys follow the math that you would get tangent of 57 minus tangent of 16 equals 55 over 6 tangent of 16? If I subtract, they're both y's, I can pull out a y. And what's the last thing to solve for y? Divide and throw it all in your calculator. And once you have y, wait, what were they asking for? Ugh, that's all right. Once you end up with whoever y equals, you could just take him, and I would plug him back in the easiest formula I see. Actually, I would plug him in here. It's even easier. Then you would answer for x. Kiddos, I did a nasty problem to end just because maybe you'll have some tricky ones in homework. I've narrowed down the homework. It's all up to date on Google Classroom. I'll see you tomorrow. Corrections due by the end of today. And this is a mess up here. If I'm not in my room after school, I'll be out at the woods if it's dry enough. Very questionable. Bye, guys.